October 29, 2025. In a televised panel with the Harvard-Smithsonian Center for Astrophysics, Dr. Avi Loeb, the astrophysicist known for proposing Oumuamua might be artificial, just added a new object to his watch list, 3I/Atlas. Until now, Loeb had remained cautious, avoiding public speculation on Atlas. But in a segment that's now gone viral, he said, the movement of 3I/Atlas behind the sun is not typical for natural objects. We must be open to all possibilities, including artificiality. That word, artificiality, has set the scientific world ablaze. Why now? Because Atlas hasn't just vanished behind the sun. It has changed velocity vector, slightly, subtly, but enough to trigger recalculations of its post-perihelion trajectory. And according to Loeb's team, that shift is not accounted for by solar gravity or known outgassing models. Something else caused it. In his own words, it's as if the object adjusted, like a correction burn. Not random drift, controlled change. That's not language you hear often in comet reports. Even more stunning, Loeb confirmed that his Galileo project is now allocating resources to monitor Atlas exit trajectory, not just from ground telescopes, but from sky-based platforms designed to detect non-natural movement. This marks the first time since Oumuamua that Loeb has publicly committed to active surveillance of an interstellar object, and he's not alone. In the hours since his statement, multiple independent astrophysicists have acknowledged similar anomalies, noting Atlas deceleration behind the sun as inconsistent with solar tidal influence. Which brings us to the bigger question. If 3I/Atlas adjusted its path, who or what made that decision? For weeks, 3I/Atlas followed a predictable path, hyperbolic, inbound, consistent with a long-period interstellar object. But that changed the moment it passed behind the sun. On October 26, orbital data from ESA's solar orbiter showed a slight divergence, a 0.003 Australian dollars lateral shift in Atlas' projected trajectory. It didn't curve like a natural object pushed by outgassing. It nudged, as if it had been adjusted. NASA called it a thermal variation, a solar-induced pressure imbalance. But orbital dynamics teams weren't convinced, because that same pressure imbalance would have produced a chaotic tail signature, and it didn't. Atlas remained geometrically stable, its coma symmetrical, its dust jets minimal. In other words, no signs of natural force acting. And yet the shift happened. Avi Loeb's lab analyzed the delta V, the change in velocity. It measured just under 3.2 centimeters per second. That's minuscule by terrestrial standards. But in interstellar terms, that's massive, enough to alter its path by thousands of kilometers over the coming months. Loeb's team simulated known non-gravitational effects, including solar radiation pressure, Yarkovsky effect, and asymmetric outgassing. None matched the precision of the shift. One researcher commented, "It was like someone tapped the brakes, not a rock venting gas." Even stranger, the shift occurred during a solar calm. No flares, no CMEs, no disturbances to explain an external influence. And there's precedent here. In 2017, Oumuamua exhibited a similar unexplained acceleration, which Loeb famously attributed to possible light sail technology. But unlike Oumuamua, Atlas' shift wasn't away from the sun. It was sideways, a maneuver, not a thrust. And that raises a question Loeb wasn't afraid to ask. If this object corrected course, then it may not be passive. The implications are massive, because for a shift that's subtle, that controlled, you need internal systems, stabilizers, a method of vector correction. And if Atlas has that, then we may not be looking at a comet, or even a fragment, but a vehicle, something that entered our system for a reason, and is now adjusting to stay hidden just a little longer. For Avi Loeb, 3I/Atlas isn't just familiar, it's hauntingly familiar. Back in 2017, Loeb shook the scientific community by proposing that Oumuamua, the first known interstellar object, might be artificial. At the time, the idea was dismissed as fringe speculation. Now, it's gaining traction again, because 3I/Atlas is following a script eerily similar to Oumuamua's, but with even more structure. Here's why Loeb is paying attention. First, the non-gravitational movement. Oumuamua accelerated away from the sun with no visible jets, no outgassing, nothing a telescope could resolve, yet it changed course. That mystery still hasn't been solved. Now, 3I/Atlas, nearly a decade later, has done the same, except this time the trajectory shift was lateral, not radial. That implies course correction, not solar push. Second, the low outgassing profile. Both objects exhibit unusual thermal behavior. For Oumuamua, no dust coma ever appeared, even when it passed within 25 cents of sun. That ruled out ice as the source of its acceleration. Atlas, too, shows remarkably low activity, despite its proximity to solar heat. Its brightness profile is consistent, controlled, and lacking the chaotic flare-ups typical of icy cometary bodies. Third, and most compelling, the reflected light curve. Both objects show an odd, non-random brightness pattern, a light curve that suggests tumbling or possibly structured surfaces rotating with intent. Loeb described it as the kind of pattern you'd expect from a panel, not a pebble. He's referring to reflective materials. With Oumuamua, he proposed a thin, sail-like structure, maybe a defunct probe or scout. With Atlas, he hasn't said the word craft yet, but he's edging closer. In his latest paper draft, Loeb writes, the combination of lateral drift, symmetric brightness retention, and minimal sublimation suggests an object of high surface uniformity and thermal stability, consistent with an engineered material. That's as close as a Harvard astrophysicist gets to saying, this might be built, but here's the wild part. Atlas is larger than Oumuamua. It's also slower, and it didn't just pass through. It stayed. It maneuvered, and it parked. Behind the sun, at a distance consistent with observation avoidance. If Oumuamua was the warning shot, Atlas may be the main event. And for Loeb, the question is no longer, could it be artificial? It's, how long has it been here, and what is it waiting for? The idea sounds like science fiction. But the data? It's forcing serious scientists to ask a radical question. What if 3I/Atlas isn't common at all, but a surveillance platform? Let's look at the pattern. It arrived on a hyperbolic path, just like Oumuamua. But unlike a flyby, Atlas slowed down, shifted laterally, and then disappeared behind the sun. It didn't need to slam on the brakes. Just a few centimeters per second in deep space is enough to alter course dramatically. And that's exactly what it did, at the precise moment it passed out of Earth's view. That's not just strange. It's strategic. Think about it. If you were sending a probe to study a civilization, you wouldn't drop it in plain sight. You'd position it somewhere invisible, somewhere you could observe without being observed. And there's no blind spot greater than the solar anti-Earth point, directly behind the sun, where radio silence and visual occlusion are complete. Ground telescopes can't track it. Radio arrays lose signal. And even space-based assets suffer lag and interference. That's where Atlas went. But it gets weirder. ESA's solar orbiter picked up localized UV pulses from a region, short bursts with rhythmic intervals, not natural solar flares, not background noise, but timed emissions spaced at 19-minute intervals. Then came the signal riding the solar wind, a low-frequency pattern embedded in electron flux, barely detectable without target analysis. It wasn't loud, but it was structured, predictable, encoded. Together, this paints a picture not of chaos, but a function. Avi Loeb hasn't said stealth platform out loud, but his latest public statement edged close. If Atlas is emitting periodic energy signatures from a solar shielded position, then we must consider non-natural intent. Why periodic? Why modulated? Why from a location we physically can't reach? One possibility is communications, bouncing signals off the sun or receiving data without detection. Another is sensing, using our star as a gravitational lens, a theoretical method to observe planets with incredible precision, and Earth, perfectly positioned for that kind of targeting. If true, we may be part of an ongoing observation, one that began the moment we launched radio into the void. And if it's not alone, if more objects join it in formation, then we're not just looking at a structure, we're looking at a system, one that might be watching right now. For months, astronomers tracked 3I/Atlas as it approached the inner solar system. Its path was odd but stable, a hyperbolic curve that screamed interstellar origin. But now, with mounting anomalies and subtle maneuvers, a chilling possibility has emerged. What if this was always the plan? Not just a comet on a wild ride, not a fragment ejected from some distant star, but a vehicle programmed precise with a destination in mind, the far side of our sun. Let's look at the trajectory. Atlas didn't take the fastest route. It didn't dive in and slingshot out. Instead, it curved just enough to graze the ecliptic, then slid perfectly into Earth's blind spot. No one aims for that spot by accident. And if the slight trajectory shift wasn't natural, if it was a deliberate adjustment, then this isn't just a rock with attitude. It's a probe with instructions. And that raises questions no one wants to answer. Who gave those instructions? When were they written? And what exactly is the mission? Loeb's Galileo team is modeling possible outcomes. One theory: the structure left near the sun is an observer node, a stationary asset designed to scan Earth's orbital plane from a hidden vantage point. Why there? Because it offers the most persistent view of Earth's traffic, emissions, satellites, and solar interactions, all from a point where our telescopes can't see. Another theory is even more unsettling. What if Atlas isn't just parked, but waiting for what? A signal? A launch window? Or a response to something we haven't sent yet? When you look at it like that, everything changes. The arrival date, the maneuver, the communications like pulses, even the silence from agencies like NASA, ESA, and JAXA. They're not confused. They're careful, because if this is the first step of an encounter, even a passive one, every word matters, every move counts. And the fact that Atlas executed this maneuver in the only part of space we can't watch in real time, that's not an error. That's a message. It's telling us, you're not the only ones who can observe. The clock is ticking. In just a few days, 3I/Atlas will reemerge from behind the sun, and what it brings with it could define the next era of space exploration. Astronomers around the world are already watching. NASA's IRIS and ESA's Solar Orbiter are positioning. SETI has recommissioned its Allen telescope array for targeted scans. And the Galileo project? It's going full spectrum, radio, optical, infrared, even gravitational anomaly monitoring. Why? Because no one knows what's coming. When Atlas vanished behind the sun, it was still shedding mass, barely. But with minimal outgassing and a stable coma, it didn't look like a typical comet. It looked dormant. But that's what worries scientists the most. What if dormancy wasn't decay, but deliberate? A power down, a mode shift, a waiting phase. And what happens when it returns to full solar exposure, no longer hiding, but emerging? Here's what experts are preparing for. Unexpected acceleration. If Atlas changes speed or heading again, it will confirm active propulsion or guided drift, an absolute red flag for natural models. Secondary objects. If new bodies emerge, in formation with consistent spacing, it will support the convoy hypothesis. Already, 9 objects have been loosely tracked near its path. Altered reflectivity. If the light curve changes or we detect structured surfaces, it could indicate material that's not just rocky or icy, but engineered. Communication signals. SETI is preparing to scan for narrowband emissions and modulated waveforms, especially those embedded in background cosmic noise or solar wind irregularities. But here's the truth. No one knows what Atlas looks like now. It could emerge intact. It could have fractured. It could have shed its shell, revealing something far stranger beneath. A structure, a craft, or nothing. And if it's nothing, if the anomaly doesn't return, that might be the most chilling outcome, because it means it moved again, possibly toward us, or toward another point of interest. This is not just about curiosity anymore. It's about readiness. The moment 3I/Atlas clears the sun's glare, every scope on Earth will point toward it. And whatever we see, it could change our place in the cosmos forever. Right now, there's a hush over the scientific world, a silence that isn't from lack of data, but from what the data might mean. 3I/Atlas is more than a comet, more than a trajectory anomaly, more than a reflection of Oumuamua's mystery. It's a test of our instruments, of our theories, and of our ability to face the unknown without flinching. Because if Avi Loeb is right, if Atlas is maneuvering, if its behavior is deliberate, then we may be witnessing the first structured arrival in human history. But unlike the movies, there's no booming soundtrack, no dramatic landing, no message carved in stone, just silence, movement, pattern, and a growing list of scientists willing to say what they never dared say before. This doesn't behave like a rock. So now we wait for it to reappear, for the signals to return, for the structure, if it's still there, to show its face again. And when it does, one thing is certain. The question won't be whether we're being watched, but whether we're ready to be seen.